Hello and welcome to the GCSE Chemistry tutorial for topic C4 Chemical Changes. This tutorial is part 4 and covers electrolysis. Electrolysis involves passing a direct current through an electrolyte. Electrolyte is the liquid or molten dissolved ionic compound you're trying to break down. Electrolysis involves two electrodes. These are solid rods made of graphite or something similar that conducts electricity. When electricity passes through the electrolyte, it breaks it down into ions. Positive ions move towards a negative electrode called the cathode. Here they gain electrons, and that's called reduction. Negative ions move towards a positive electrode called the anode, where they lose electrons, and this is called oxidation. By breaking down the ionic compound, you then can form different elements. You can use electrolysis to extract metals from ores. We've looked at that in a previous topic. Here we use electrolysis to extract aluminium from its ore, bauxite, or aluminium oxide. In summary, at the anode, or the positive electrode, you can see that oxygen loses electrons to form oxygen gas, which is oxidation. At the cathode, or the negative electrode, the metals gain electrons to form aluminium, and that's called reduction. These are called half equations. You do need to know them. Molten ionic compounds are easier to break down by electrolysis, but sometimes you can mix the compound with water, and that means they're aqueous. Now the issue then is you've also got the ions from water, OH- and H+ ions, so they can also be released. So what's released depends on the reactivity of the ions in the solution. So you need to look back at the reactivity series and look at the position of hydrogen in this reactivity series. At the cathode, or the negative electrode, if hydrogen ions are present, then hydrogen gas will be formed if the metal ions are more reactive than hydrogen. If the metal ions are less reactive than hydrogen, then the metal will be formed instead. At the positive electrode, or the anode, if OH- ions and halide ions are present, then the halogen will be formed. But if there are no halide ions and only OH- ions, then oxygen gas will be formed. Let's look at some examples of this. If I was to carry out the electrolysis of copper sulfate solution, there's 4 possible ions that could be produced: Cu2+, SO42-, H+, and OH-. At the cathode, copper is less reactive than hydrogen, so copper is produced, shown here. At the anode, there's no halide ions, so oxygen and water are produced, as shown here. You need to learn these half-balanced equations. Another example is the electrolysis of sodium chloride solution. Remember, sodium chloride solution contains water as well. So there's 4 ions present: Na+, Cl-, OH-, and H+. So what's produced? Well, you'd pour the solution into a beaker and add the electrodes. Because what you're producing is gases, you would use inverted tubes as shown here. You can add a direct current and collect the gases produced. You produce chlorine and you produce hydrogen. This is because at the cathode, sodium is more reactive than hydrogen, so hydrogen is produced. At the anode, chloride ions are present, which is a halide, so chlorine gas is produced. The test for this: chlorine bleaches damp litmus paper, and hydrogen gives a squeaky pop with a lit splint. If you pause the tutorial now and try and answer these questions. What are the 2 electrodes called? The cathode is the negative electrode, the anode is the positive electrode. When molten sodium chloride is electrolyzed, what is formed? Well, molten sodium chloride just contains sodium and chloride ions. So at the cathode, you'd form sodium, at the anode, chlorine gas. Number 3, when aqueous sodium chloride is electrolyzed, what is formed? Well, this time you've got different ions involved. So this time at the cathode, you would form hydrogen gas, and at the anode, you would still produce chlorine gas. In summary, we've looked at electrolysis and a practical to carry out electrolysis.